Mumbai is the most populated city in India with a current population of 13.9 million inhabitants. Around 2.2 billion litres of water are needed each day, and the demand continues to grow. The water supply pipes nearly all date back to the English colonial period. Since they were laid some 100 years ago, the size of the population has increased by a factor of 14. The existing water mains have not evolved to meet the changing demands. Next to the existing old pipelines, a new 70-kilometre-long water main is being constructed with a diameter of 3.5 meters. It will connect the city of Mumbai with the Modak Sagar water reservoir and provide additional drinking water for the population. ÖSTU-STETTIN specializes in highly challenging international underground projects. The company has a saying, if you want to build high, then you must first dig deep. And this was part of the high motivation when they started the project in 2008.
ÖSTU-STETTIN had already carried out many large-scale international projects. The project in India has been jointly managed in cooperation with a local Indian partner, Prativa. ÖSTU-STETTIN has, however, been responsible for the technical leadership.
A tunnel 100 meters underground must be constructed for the high-throughput water main. Its starting point is a massive shaft close to the reservoir. This shaft is the hub and key location for the project. The water level of the reservoir varies enormously over the year. In the monsoon season, it collects over 95% of the annual rainwater precipitation. In between, the water level falls on occasions to frighteningly low levels. The new drinking water pipeline follows these variations in level by drawing water at different depths from the reservoir. 3 intake structures are connected together by the shaft, and locks at different levels regulate the intake of water. The tunnel boring machine had to be transported from Austria via sea route to India. Piece by piece, it is lowered down the shaft so that work on the tunnel 100 meters below can start.
That is a Robbins open-design tunnel boring machine. A cutter head with disc cutters and an overall diameter of 4.1 meters. The complete machine, including the cutter head and the trailer, measures about 250 meters in length. To the rear is the gripper, which pushes against the tunnel walls and allows the propel cylinders to extend and move the whole machine forward.
The huge machine measures an incredible 250 meters in length. The attached trailer unit is like a small factory. In addition to the main hydraulics and storage tanks, it carries transformers, air supply systems, and a range of supplies for mining. The hydraulic pumps work at pressure up to 300 bar. Electrical compressors produced compressed air which, among other necessary operations, is used to apply sprayed concrete onto the walls of the tunnel. The tunnel boring machine left the shaft behind well over a year ago. Meter for meter, it has carved its way through hard rock, carrying the tunnel forward over 4.5 kilometers. 2 kilometers of solid mountain still lie ahead. A diesel locomotive now runs between the shaft and the boring head, synchronized with the boring cycles to bring supplies and remove waste. The climate inside the mountain puts a heavy load on man and machine. The combination of heat and high humidity is hard to bear, especially for Europeans. The thermometer never drops below 45 degrees centigrade. Added to this is the continual pressure to keep the project on time and in budget. A burdensome byproduct of this whole process is the enormous amount of heat generated. Within 10 meters of the actual cutter head, the ambient temperature rises to above 52 degrees centigrade. The fresh air blown in from the surface is here absolutely necessary, even if it does little to promote cooling. A further problem is the enormous amount of dust that is created. The level of noise, heat, humidity, and dust at the rock face is almost unbearable. With every turn of the cutter head, the tungsten carbide disc cutters bite deeper into the rock. The circular face of the cutter head is 4.1 meters in diameter and is fitted out with 28 disc cutters. Each works with a force of 20 tons on the hard rock. With this project, they have to cope with a particularly hard basalt rock. Under such extremes of pressure, the cutters throw out pieces of rock the size of a fist. In order for the machine to hold itself stable, it is braced by grippers against the tunnel wall. From this fixed position, the powerful forward propel cylinders push the cutter head against the hard rock face with a force of up to 700 tons. The machine is guided through the mountain by the latest measurement technology. The orientation underground is enabled using data collected by geological surveyors. A laser-targeted steering system holds the boring machine precisely on course. This is the only orientation instrument that the operator has at his disposal. Nevertheless, the complex target system ensures that breakthrough occurs exactly on target and according to plan. Buckets in the rotating cutter head scoop up the rock waste from the floor of the tunnel and deposit it onto a belt conveyor. The belt conveyor transports the excavated rock directly to the transfer point, where waste material is loaded into waiting wagons. On a regular cycle, the diesel locomotive pulls the set of 15 wagons between tunnel face and the shaft opening. The train arrives at the hopper at the base of the shaft loaded with 150 tons of excavated material. Each wagon holds 5 cubic meters of material. The apron feeder was developed by ÖSTU-STETTIN and has already proven itself in 18 months of continuous operation without a single breakdown. It works reliably under extreme environmental conditions. Ton after ton, it conveys excavated material from the hopper and loads it into the buckets, huge containers, each with a capacity of 15 cubic meters. A powerful gantry crane lifts the oversized buckets from 100 meters below up into the daylight. At the surface, the bucket discharges its contents directly next to the shaft. Checks are made at regular intervals by the site management from ÖSTU-STETTIN to monitor progress at the construction site and ensure the status of the technical equipment. Here, the work is continuous 24 hours a day, 7 days a week, all year round. Shift teams change over every 12 hours. The project is complicated by certain cultural differences, but more particularly by the harsh working conditions underground, the dust and the enormous heat, sometimes above 60 degrees centigrade. The 28 disc cutters on the 4-meter diameter cutter head have been working for 1.5 years, and the underground power plant has been moving meter for meter towards its goal, 7 days a week without a break. The piece of high-tech equipment 250 meters long has chewed its way through the rock with great effort, but always with total reliability. By April 2011, the time has come. The breakthrough at the last rock face occurred exactly on time and at the right place. The joy on the successful completion of the project was immense for everybody involved. As the last wall of dividing rock fell, the jubilation was ecstatic. Through tremendous efforts of people and technology, the goal has finally been achieved: a secure water supply for the growing city and quality of life for millions. ÖSTU-STETTIN, Construction unlimited.